Alright, moving on to the next section of our vector operations. On this first one, we need to get f plus h. Well, f is 3, 4. And h is -1, -2. So to combine those, you can just combine the components 3 plus -1 and 4 plus -2. And you get 2, 2. And on B, we need to find the magnitude of f plus h. And remember, the formula for that is the square root of x squared plus y squared. And so we already got f plus h, it's right there. So that's a little bit convenient. We're now just going to square those components, add them together, and get our square root of that. 2 squared is 4. And so we're looking at the square root of 8, which is actually the answer there. But if you want to make it, round it to a decimal there, you're looking at 2.8. On the next section, we have to do -2h minus 4h, and then get its magnitude. Well, let's get -2h first. That's -2 times -1, -2. And then we need to subtract off 4 times h, and h is 3, 4. I'm going to distribute those through. -2 times -1 is positive 2. -2 times -2 is positive 4. When you subtract off, well, 4 times 3 is 12. And 4 times 4 is 16. And now that we have that, we can do the subtraction. You subtract corresponding terms, so 2 minus 12, 4 minus 16. And so 2 minus 12 gives us -10. And 4 minus 16 gives us -12. So this is 2h minus 4f. And we need now to get the magnitude of that. So you take each of those components, square it, add them together. -10 squared is 100. -12 squared is 144. And if you combine those, you're looking at 244, which is approximately, 244 square root is approximately 15.6. And there you go. That's the magnitude of 2h minus 4f. Moving on to 14, we need to get w plus v. Well, to do that, you just have to combine the components of these two vectors. And when you do that, you're looking at -6 plus 5, -2 plus -4. And if you combine those, you're looking at -1 and -6. And those are our coordinates there. We need to now get the magnitude of w plus v. And to do that, you just square both those components, add them together, and then square root that. -1 squared is 1, -6 squared is positive 36, add together, looking at the square root of 37. Oh, the square root of 37 is a little bit over 6. It's approximately 6.1. And moving on to the next part, we need to get 2v minus 3w and then find its magnitude. And so to do that, we're just going to do -2 times the v, which is 5, -4. And then subtract off 3 times w, and w is -6, -2. And when you do that, if you distribute that scalar into the vector, you're looking at -10, 8 minus, not parenthesis, no, vector bracket. You're looking at negative 18, and negative 6. And to combine those, you need to combine the components. So you're looking at negative 10 minus negative 18, and 8 minus negative 6. Negative 10 plus 18 is 8. And then 8 minus negative 6 is positive 14. And so we now have negative 2v minus 3w. And we need to now get the magnitude of that. So you square each of those components. 8 squared, 14 squared. 8 squared is 64. I actually don't know 14 squared off the top of my head. Oh, it's 196. How did I forget that one? Plus 196. If you add those guys together, you're looking at the square root of 260. Which, if you do find the square root, is approximately 16.1. And moving on to 15, you need to get k minus j, find its magnitude, and then get the magnitude of each of them, and then subtract it. So this is just kind of like a little discovery thing to figure out whether these two guys end up being the same. Who knows? Right now, maybe they do, maybe they don't. Oh, if you want to do k minus j, put k down, subtract j. And if you want to subtract vectors, you subtract on components. So 3 minus negative 4, and then negative 3 minus 6. 3 minus negative 4 is positive 7. Negative 3 minus 6 is negative 9. So this is k minus j. Well, if you want to get the magnitude of that, you just take the components, square them, combine them together, and then take the square root. Square of 7 is 49. The square of negative 9 is 81. If you get that, you look at the square root of 130. So that's the official answer. If you want your decimal approximation, you're looking at about 11.4. On this one, you get the magnitude of them separately. So k is right here, 3 and negative 3. So you're going to take each of those, square them, add together, and then square root. 3 squared is 9. Negative 3 squared is 9. So you're looking at the square root of 18. And the square root of 18 is approximately 4.2. So that's k. That's this part. And then j, on the other hand, to get that magnitude, you have to do negative 4. That's not negative 4 squared plus 6 squared. Well, negative 4 squared is 16. 6 squared is 36. If you combine those, you'll get 52. And that is approximately 7.2. And so if you were to take these two numbers and subtract them, you're looking at negative 3. So negative 3 doesn't match up with square root of 130, which is approximately 11.4. So that's just a little bit of extra trivia for you. So you're looking at about 3 for your answer there in part C. On D, you're doing something on D through F, you're doing something very similar. You had to do 3 times J, and then subtract off 5 times K. I'm going to kind of distribute here, so 3 times negative 4 is negative 12, 3 times 6 is 18. When you subtract off 5 times 3, which is 15, 5 times negative 3 is negative 15. And if you want to subtract components, you subtract their, if you want to subtract vectors, you subtract their components. So negative 12 minus 15, 18 minus negative 15, which is going to give you negative 27 and positive 33. So there's our lovely vector here. That's 3j minus 5k. And we need to now get that magnitude. So you just take each of your components, square them, add them together, and then square root it. I actually don't know negative 27 squared. Oh, it's 729. And 33 squared is a fairly large number, 1089. And if you add those together, you're looking at the square root of 1818. And if you do that, you're looking at approximately 42.6. So I'm going to circle that as our answer. And on F, you need to get the magnitude of these separate pieces. Well, luckily I already got the separate pieces there, so I can just go straight to getting the magnitude of each piece. I need to do negative 12 squared and 18 squared. Negative 12 squared is 144. 18 squared is 324. So if you add those guys together, you're looking at the square root of 468, which when you do that is approximately 21.6. So that's the 3j part. That's the magnitude for 3j. I need to now get the magnitude of 5k. To do that, I need to do 15 squared plus negative 15 squared. 15 squared is 225. And if you combine them together, you're looking at square root of 450, which is approximately 21.2. And to finish up, you need to do 21.6 minus 21.2, which is that's just 0.4. So there's your final answer for the bottom here. And there's F. And